Welcome students. In this class, we are going to study the topic surface chemistry. Surface chemistry is the branch of chemistry in which we study those reactions or changes which are taking place at the interface of two phases, which can be solid gas, solid liquid, liquid gas, etc. This is applicable in industries and day-to-day lives. In other words, surface chemistry deals with all types of surface phenomenon. In this chapter, we will be studying absorption and adsorption, mechanism of adsorption, types of adsorption, application of adsorption and adsorption isotherm. First, we will see what is absorption. We know sponge has lot of holes or pores in them. Take a sponge and put it into water. What happens? This sponge is soaked up with water. That is, the sponge is going to wet uniformly throughout with water. This process is absorption. In this, one substance, that is sponge, the other substance, that is water, entering and penetrating through the surface of sponge, and they are getting uniformly distributed throughout the bulk of sponge. If so, how do you define absorption? It is a phenomenon in which one substance enters into another substance and get uniformly distributed throughout the bulk of another substance. Example of absorption. If we put biscuit inside the tree, the process what happening is absorption. Here the tea gets absorbed uniformly into the biscuit. Another example is chalk in water. When we put a piece of chalk in water, what happens? The water gets absorbed. Now I hope you are clear about absorption. Now you see, when we writing on the blackboard, the chalk powder gets stuck on the blackboard. Can we call this process is an absorption? No, this is not an absorption. In this, chalk gets accumulated on the surface of blackboard. That is, one substance gets accumulated on the other substance only on the surface. Here, the process is called adsorption. Then how do you define adsorption? It is a phenomenon in which one substance accumulates on the surface of another substance in higher concentration. Example of adsorption. When we buy a new bag or shoes from shop, we can see a packet inside it. That packet is called silica gel. Why do we have to put silica gel inside it? This silica gel will take all the moisture and they will keep it on surface. That is, silica gel absorbs water vapor. Therefore, this process is one of the best example for adsorption. Next, we will see difference between absorption and adsorption. First is absorption. It is a phenomenon in which the particles of gas or liquid uniformly distributed throughout. It is bulk phenomenon and it occurs at uniform rate. An example for absorption is anhydrous calcium chloride absorb water. Next is adsorption. It is the phenomenon in which the higher concentration of particle of gas or liquid on surface than in bulk. Adsorption is surface phenomenon and it occurs rapid in beginning but slowly decreases. An example for adsorption is silica gel that absorb water vapor. Now we discuss about some important terms in adsorption. First we will see adsorbent. What is adsorbent? Adsorbent is usually solid substance that adsorb another substance. Example, silica gel, charcoal, clay, etc. Adsorbent refers to the molecular species that gets adsorbed on the surface. Next is desorption. Desorption is the process of removal of adsorbed substance from the surface on which it is absorbed. These are some terms that are used in adsorption process. Some commonly used adsorbents are silica, activated charcoal, alumina, bentonite clay, zeolites, baggies. You will be more clear about when we see some more example of adsorption. First one is accumulation of dust on our skin when we travel in region of heavy traffic. Next, adsorption of dyes like methylene blue by charcoal. Protection from poisonous gases. Solution of rose sugar become colorless when passed over bed of animal charcoal. Air becomes dry in the presence of silica gel. Next, we discuss about mechanism of adsorption. Why the adsorbate particles are attracted towards the surface of adsorbent? Maybe this question has arisen in your mind. So, do you want to know the solution for this problem? Yes. So, let us discuss and find out the solution for this problem in its mechanism. Let us discuss the mechanism of adsorption. Adsorption is surface phenomenon. It arises because of unbalanced forces on the surface of solids and liquids. The surface is under tension due to this unbalanced force. So, the surface of the solid or liquid tend to satisfy their residual forces by attracting and retaining the molecules of other species when brought into contact with them. And it is an exothermic process, which means that energy is liberated during this process. The amount of heat that gets evolved when 1 mole of the adsorbate is adsorbed on the adsorbent is known as enthalpy. At constant temperature and pressure, adsorption occurs spontaneously. Now, there are two kinds of adsorption, that is physisorption and chemisorption. Physisorption is defined as the process in which the structure of an atom or a molecule is unsettled. Physisorption occurs due to van der Waals forces and it is reversible in nature. It is considered as non-specific. Physisorption occurs in low temperature. The process of physisorption decreases with an increase in temperature and it forms multimolecular layer. Next is chemisorption. On the other hand, chemisorption is defined as the process in which the chemical bonds are formed through the interaction between adsorbate and adsorbent. Chemisorption occurs due to formation of chemical bond. It is irreversible and specific in nature. Chemisorption occurs at high temperatures. The chemisorption process increases with increase in temperature. It forms unimolecular layer. Next is factors affecting adsorption. First one is nature of gas. Easily liquefiable gases easily gets adsorbed. Nature of adsorbent. More the surface area per unit mass of the adsorbent, more will be the adsorption. Next factor is temperature. The process of adsorption increases as temperature decreases. The next is pressure. Magnitude of adsorption increases with increase in pressure. Now, let us discuss application of adsorption. The principle of adsorption is employed for the preparation of gas masks, adsorption indicators and used in chromatographic separation, used for removal of coloring matter, heterogeneous catalysis, controlling humidity and for curing diseases, in fourth flotation process, production of high vacuum and also used in purification process. Now, we are going to study about adsorption equilibria. When an adsorbent comes in contact with adsorbate, adsorption takes place. After a long time, the adsorbent and adsorbate reaches at equilibrium. That is, W is equal to function of P and T, where W is the equilibrium uptake of adsorbed adsorbate in unit of gram per gram or mole per gram. T is the temperature and P is the pressure. If the temperature is kept constant, the change in equilibrium uptake against the pressure is called adsorption isotherm. That is, W is equal to function of P. When the gas pressure is kept constant and the adsorbent temperature varies, the change in amount of adsorbate against the temperature is called adsorption isobar. That is, W is equal to function of T. A simplest type of adsorption isotherm at different temperature is shown in figure. In the figure, first one is the adsorption isotherm at 195 Kelvin. Second one is the adsorption isotherm at 244 Kelvin. And the third one is the adsorption isotherm at 273 Kelvin. It is clear from the figure that the adsorption limit, that is x by m, increases as the pressure increases and reaches a maximum corresponding to the pressure P, which is called equilibrium pressure. At pressure P, the volume of the adsorbed gas becomes equal to the volume of the dehydrated gas, so that the extent of the adsorbent remains constant even when the pressure is increased. This state is called saturation state and pressure is called saturation pressure. Some important types of isotherms are Freundlich adsorption isotherm, Lachmuir adsorption isotherm and Bett adsorption isotherm. In this class, we also study about Freundlich adsorption isotherm. This isotherm was given by Freundlich in 1909. Freundlich suggested an equation to describe the variation of adsorption per unit mass with the pressure P. Freundlich equation is x by m, that is equal to k into p to the power 1 by n, where x is mass of the gas adsorbed at equilibrium, m is the mass of adsorbent, k and n are constant depending on adsorbent adsorbate pair. Now, if we take the logarithm of above equation, then the equation becomes log x by m is equal to log k plus log p to the power 1 by n. This can be written as log x by m, that is equal to log k plus 1 by n log p. To test the validity of Freundlich isotherm, we can plot log x by m on the y axis and log p on the x axis. If the plot shows a straight line, then the Freundlich isotherm is valid, otherwise it is not. The slope of the straight line gives the value of 1 by n, while the intercept on the y axis gives the value of log k. At low pressure, the graph is an almost straight line, which indicates that m is directly proportional to pressure. This may be expressed as x by m directly proportional to P, that is x by m equal to Kp, where K is a constant. At high pressure, the graph becomes almost constant, which means that it becomes independent of pressure. Then the equation becomes x by m, that is equal to K. From the figure, it is clear that at low pressure, the adsorption is dependent of pressure, and at high pressure the adsorption is independent of pressure. Next, we discuss about limitation of Freundlich adsorption isotherm. Freundlich isotherm only approximately explain the behavior of adsorption. The value of 1 by n can be between 0 and 1. Therefore, the equation hold good only over a limited range of pressure. When 1 by n is equal to 0, x by m is constant. The adsorption is independent of pressure. When 1 by n is equal to 1, x by m is equal to Kp. That is, x by m is directly proportional to pressure. This is about Freundlich adsorption isotherm. So, dear students, we are concluding this class with a recap of things we are studied. Today, we saw what is absorption, then we studied in detail about adsorption, mechanism of adsorption, types of adsorption, application of adsorption and adsorption isotherms. Thank you.